And once you combine your numerators on top of your common denominator, just make sure everything is then factored completely so you can simplify to lowest terms. Now the extra step now is if you don't have common denominators to begin with, you have to create them. And then continue like that. Okay, so 5 over 6y minus 9 over 5y. Now, as a reminder, our LCD is the product of the unique factors in the denominator. We're talking about factors, so that requires factoring. Notice that you factor denominators completely. Do we bother with the numerators? No. You don't know what numbers are going to be in your numerator at the beginning because you haven't combined them yet, so don't make more work for yourself. Ignore the numerators. So if you need to find an LCD, first you have to make sure all your denominators are factored because your LCD is just multiplying each unique factor. Okay? Product, or multiplying all of the unique factors, so you need factors. Okay? So, I've got a minus. I've got a rational minus a rational. Okay? So I know I need common denominators. Do I have them? No. Yeah, they both have y's, but if they've got different coefficients, they're not like, yeah, they're not, well, they are like terms, but they're not common denominators. They have to be exactly the same to be a common denominator. Now, I'll go off to the side and I find my LCD. Now, if you have denominators that are binomials, okay, we're going to deal with those in a second. Right now, these are just free-floating factors. There's nothing to factor here. This means 6 times y. It's linear. There's no way to break that down further. Okay? So these are already factored completely. There's nothing to factor. They're already linear, no GCFs. Okay? So first you're going to look at any numbers, any free-floating numbers. Okay? You got 6 and 5. I don't mean numbers that are locked up in binomials like x plus 6 or x minus 5. I mean free-floating numbers outside of parentheses. Okay? So if you have any numbers that are free-floating, then you just treat those just as if you had denominators of 6 and 5. And what is the LCD for 6 and 5? The least common denominator. Not a factor. 30, right. If you just had fractions that had a denominator 6 and a denominator 5, you would use a common denominator of 30.
Wait, to find the LCD, does it multiply the 6 times 5?
That will find you a common factor always, but it's not always the least common factor. In this case it did, but sometimes, for example, 8 and 12. 8 and 12 have an LCD of 24, right? But if you just multiply 8 times 12, you get 96. That is also a common denominator, but it's not the least, and you're dealing with much bigger numbers. Okay? There's a term called relatively prime. 5 is prime, 6 is not. Okay? So separately, they may or may not be a prime number, but relatively prime means that the numbers don't have any common factors other than 1. If you have relatively prime numbers, 6 and 5 don't share any factors, then you can just multiply them together to get your LCD. But like 8 and 12 are not relatively prime because they have a factor other than 1. They share factors of 2 and 4. They're not relatively prime, so they're not going to. If you multiply them together, you won't get the least common denominator.
Okay. So that work only if one of the numbers is prime?
Not if one of the numbers is prime. It's what they're called relatively prime. It means those two numbers, they might both be prime, they might be both not prime, or one prime, one not. It doesn't matter. Relatively prime means they don't have any common factors. 6 and 5, the factors of 6 are 1, 2, 3, and 6. Factors of 5 are 1 and 5. The only common factor they have is 1, which means that they are relatively prime. Okay? Doesn't matter whether they're individually prime. Relatively prime means they share no common factors other than 1. In which case, multiply them together, there's your LCD. But if they share any other factors, they are not relatively prime, and the LCD is not when from multiplying. That's a common factor, but you're not going to get the lowest one if you multiply them. Yeah, sure. Okay. So, let me just go on a separate piece of paper so I don't mix it up with my notes. So, for example, if you have 9 and 6. So let's say we're adding 5/9 plus 1/6. Okay. Now, a common factor, a common denominator would be 54, 9 times 6. Okay? And you can change this to something over 54 plus something over 54. Because 9, to get from 9 to 54 is times 6, right? And so this would be 30. And this would be 9. Okay? So this would be 39 over 54.
You can still break it down.
Yeah.
Only.
You can still reduce it, right? So you can reduce it, you can divide the top and bottom by 3. It's hard because you're dealing with bigger numbers, it's asking for more careless mistakes, it's harder to see, you can reduce it. You divide this by 3, you get 13, and you divide this by 3, you get 18. Huh? And that's correct. There's nothing wrong with that. But these are not relatively prime, okay? Because, so if you multiply them together, you get a common factor, but they do share a factor other than 1. What common factor do these guys share? 3. Since they share a common factor, they are not relatively prime. Therefore, you can multiply them together to get a common denominator, but it won't be the least. So to find a least common denominator, always, whether they're relatively prime or not, a least common denominator is always the biggest one or bigger.
What do you mean by that?
I mean, look at these, 9 and 6. Which one's bigger? 9. Okay, so is 9 a multiple of 6? No. So it's either going to be the biggest one, 9, and that didn't work, or it's going to be bigger. And so at that point, you start counting by 9s. So if 9 doesn't work, start counting by 9s. 18. Does that work? Yeah. Okay? And you just count by 9s. If 9 doesn't work, you count by 9s until you find one that does. So your LCD is 18. So to get from 9 to 18 is times 2, so this becomes 10. To get from 6 to 18 is times 3, so this becomes 3, and you end up with 13 over 18.
I was just going to do it times 3.
Yeah.
Times 2.
Yeah. To get from, yes, to change to a common denominator is times 2, so times 2 on, it's being fair. It's a factor of 1. Okay? Factors of 1. To make this 18, it's times 2 times 2, right? To make this 18 is times 3 times 3. 2 over 2 equals 1. Multiplying by a factor of 1 is the identity. It changes nothing. That's why this is a fair move. Any number over itself equals 1. So if you have to multiply this times 2 to turn it into the common denominator, then as long as you're fair to the top, you did not change the value. 5/9 and 10/18 have the same value. Okay? If you have to multiply this times 3 to make it be the common denominator, as long as you do the same things at the top, this means you're multiplying by 3 over 3. You're multiplying times 1. Multiplying times 1 is the identity. The value has not changed. It is a fair move. Okay? Now, I'm glad this came up because this right here, what we're doing right here, multiplying the top and bottom by the same thing, is exactly what we're doing with more complicated ones. So you understand that with fractions, and you understand it with polynomials as well. Okay? In the case of this one we were looking at, because we just had some free-floating numbers, we just had to treat those as regular LCD, okay? Which, in this case, it's not 6. You look at the biggest one. 6 is not a multiple of 5, so 12, 18, 24, 30. 30 works. Okay. And because they were relatively prime, yes, you could go straight to just multiplying them if you recognize that concept. Okay. Now, what else do they have in common? A y. How many times does y appear in any one denominator? One time, right? So we're not going to do y squared or 2y over here. We're just going to do a single y. Our LCD is the product of the unique factors, and unique factors means at most how many times does each factor appear in any one denominator. Just because it appears twice doesn't make this 2y or y squared. It appears at most once in any denominator, so it must be used in the LCD. And the LCD, remember, is a product, so this is just 30 times y, or 30y. Okay. So, how are we going to, I'm going to rewrite the problem just so we can see the original still. I'll leave myself a little room as well. Okay. This is some of the strategy I'm starting to show you to organize in an efficient way.
Did you make the 9?
Yes, thank you. Yes, that should be 9. All right. So your goal now that you found the LCD is to make each denominator match that. What do I have to multiply this by so that this matches that?
5.
Right. So times 5, and as long as I'm fair to the top, all I did was multiply this whole term by 1. 5 over 5 is 1. That's the identity. It was a fair move. I did not change its value because I had to multiply by 5 on the bottom to make it match. As long as I did it on top, it's fair. Okay? This is a factor of 1 thing again. How do I make this match that?
6.
Right. So times 6 will make it match, so as long as I'm fair to the top, I'm good. Okay. So that becomes 25 over 30y minus 54 over 30y. My denominator is common, It doesn't change. The pizza still has 30Y size slices. How many total slices do I have? Negative 2.
Negative 29.
Right, 25 minus 54. Yeah, once your denominator is the same, you just combine your numerators. 25 minus 54. Okay. Now, for our final answer, remember, a negative on top or on bottom means the entire thing is negative. So, to be proper, well, hello, 29 over 30y, the entire thing is negative. And that's really the proper way to write it.
If you were to leave that negative.
It's not wrong. It's not mathematically wrong. It's just better form. Okay? Make a point of if the numerator or if they're both negative, that cancels out to positive. If one is negative, it doesn't matter which one. That's the lovely thing about a negative 1. It doesn't matter where you put it. It just makes the whole thing negative. Okay? 7 over x squared plus 3 over x. Now, we do not. And I'm just going to go ahead. You don't have to do this, but for illustration purposes, so you see what we're working with here, what this means is, while these aren't like binomials, these aren't like, trinomials or binomials to factor, we can expand. If we just have something with an exponent, we can expand it. It's sometimes easier for our brain to see. Okay? And so our LCD is the product of unique factors. What unique factor do we have? What's something one or both of them have? X. So X is a unique factor. Whether they both have it or not, if you see an X, that's a factor. Now, what's the most number of times X is used as any one denominator? 2 times. So we have to include X squared. Okay? We give each factor, each unique factor in the denominator, an exponent that stands for the most number of times it's used in any one denominator. Okay? Yes? Oh, sure.
That's the same thing as saying when you cancel it out, you're going to cancel out one of those x's, so you're still left with that x.
If you go backwards, yes,
Okay.
exactly. So this already has the common denominator, but when you're making things have common denominators, you're always multiplying them up. Okay? So if one of them has 2 and the other one has 1, you have to have 2. Okay? If a factor is used twice, a factor here is x, and if it's used twice in one of your denominators, it has to be used twice for your LCD. Otherwise, you're not going to be able, you have to divide down instead of multiplying up, and that doesn't really work well for common denominators. Okay? So you're always going to be wanting to multiply the smaller ones up to whatever the bigger one is. So now this is not x cubed. It doesn't matter that you see x 3 times. That doesn't matter. What matters is you see it at most 2 times in any one denominator. Okay? So this has 1 and this has 2. So it's 2 times that we need it, not 3 total.
So if it was x to the power of 5, then it was x cubed,
Uh-huh.
say x to the power of 5.
5, right, because it'd be 5 here and 3 here. We'd need to tack on 2 more here to match the 5 here. You always want to multiply up to what the bigger one has. Okay? So if LCD is x squared, do we already have the common denominator here? Yes, it already matches. And what do we need to tack on here so it matches? Right. So since we did that on bottom to make it match, because this means the same thing as x times x, now it matches. As long as we're fair to the top, we're good.
You don't do anything to the 7?
No, because it already had x squared. If it already has the common denominator, there's nothing you're tacking on to make it match because it already matches, so don't put anything on top either. Yeah, that would be an unfair move. So we've got x squared on the bottom, that our denominator is the same, and we combine 7 plus 3x on top. Now we simplify our numerator as much as we can. Are those like terms? Nope. That's up. No. Now whether you write a 7 plus 3x or 3x plus 7, it doesn't matter. Addition doesn't matter. Sometimes it looks better for the variable to be first, but it's not required. Okay? Over x squared. There's nothing to simplify or combine in the numerator because they are unlike terms. And it can't be factored. If it could be factored, I'd check that and see if I can simplify further, but it can't be. There's not even a GCF, and it is linear.
just move the 3x to the front to make it easier on your eye, or just?
Yeah, and if you left it as like this, perfectly fine. Addition, order doesn't matter. Yeah. Usually you like to see variables first and constants second, but that's not always the case if it's subtraction. You want to be careful. You can't just change the order with subtraction. You can, but only if you bring the sign with it. Okay. Do I need common denominators? Do I have them?
No.
No. Anything you have, though, lock it up. Now, I'm going to show you, and what I'm about to do, could have done with the earlier ones, but it's really becoming more critical now. Okay? So, I've got addition. I know I need common denominators, and I do not have common denominators. So, I'm going to write my next step to be very efficient and clean. I'm going to rewrite my problem, and I'm going to write longer bars, because I'm going to leave room to tack things on. And at the same time, I'm going to fully factor any denominator that needs to be factored. Well, these don't require any factoring. Okay, they're linear and there's no GCF, but I am going to make sure I write them, lock them up. So it's very clear if I have a binomial, or that it's locked up. So I have a single x here and I have an x minus 2 here. Okay, these x's are not the same. This is x and this is x minus 2. If you've got a binomial with terms plus or minus, lock it up so you see it's one chunk. This is different than this. So these are my two different denominators, and so my second room I wrote with everything factored and locked up with room to tack things on, and now I can, because everything is factored and locked up, I can identify what my LCD is. What is a unique factor you see? And another one? Right, x minus 2. Yeah, that's why this is a factor, that's a factor. These x's are not the same. Okay?
But which one is your least?
Well, my least common denominator is the product of the unique factors. Okay. Product meaning take all of my unique factors. X is used at most once in any denominator. X minus 2 is used at most once in any denominator. My LCD is just a product, multiply each unique factor. I've got two unique factors, so just x times x minus 2. Now I want to make this match this. What do I need to tack on so this matches that? And as soon as you do that, tack it on top, and you've made a legal move.
So you don't have.
How can you make this match this? Tack on an x. We'll put it in front like that, and it can go behind. It doesn't matter whether it's in front and behind. One on top, one on bottom. I tack it on the bottom so it matches, and whatever I did down here, tack it on top.
Why did you so you did but in that case, you lost the eggs.
Right, because this was just x minus 2. I need to make it look like this. My LCD is x times x minus 2. I only have an x minus 2 here, so multiply an x time it.
So
now it matches.
Why didn't you make that 8 look like the least common denominator? Why didn't you tack on that?
Oh, it doesn't have to look like the least common denominator. I have to make my denominators look like the least common denominator. But anything I do to change the denominator must also be done to the numerator, otherwise it's an unfair move. Anything over itself equals 1. All I did to this term is multiply this term times 1. X over x equals 1. I multiply this term times 1. That's a fair move. I didn't change the value. Times 1 doesn't change anything. Factors of 1 are a very important concept. X minus 2 over x minus 2 equals 1. I had to tack it on the bottom to make it match the denominator. As long as I did it at the top, all I did was multiply this term times 1. Fair move, value didn't change. But now it visually has my common denominator. Now, this is the point where things can get really messy, because your job now is to combine and clean up the numerators. And if you have to keep writing the same thing over again with the same denominators and blah, 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 it gets very messy, very tedious. Your hand starts to cramp up the bigger problems you get. You are done with that denominator. That 8-slice pizza has 8 slices. Okay? You're not changing that. So you're done with the common denominator. There's no reason to keep writing it and dragging it along. So my final answer, I go off to the side and I write my final answer, and I leave a blank, and I can put a box around it. This is my final answer. I'm done with the denominator part. I just need to figure out what my numerator is.
You're going to cancel out that x minus 2.
I'm not canceling, no. Absolutely not, because that's going backwards. Okay? I first have to combine my numerators. Okay? I'm done with my denominator. It matches. I set it aside. I just have to add my numerators. So, since I set aside my denominator, I don't have to keep rewriting it. I just write my numerators. Just bring them down. Don't try and do this step mentally. Okay? Just write your numerator, 6 times x minus 2, plus 8x. Okay. What I did here is I made my LCDs match. Okay? I made my LCDs match. And once I made my LCDs match, then I set the denominator, the LCD, aside. And I then clean up my numerator. Okay. Make my LCD, find my LCD, make them match, then I'm done with it, so set it aside in my final answer, and then just lift off the numerator, clean it up, and then once the numerator's cleaned up, I just put it back on top. Okay. Now to clean up the numerator, first I kill any parentheses, so in this, which is either by distributing or foiling in sometimes, depending on what's been multiplied. So this would be 6x minus 12 plus 8x. Okay. Combine any like terms, 14x minus 12. Okay. And then, if it can be factored, factor it. Yeah, there's an LCD, there's a GCF in this one, right? Yeah. So you can divide out of 2, right? Leave it behind. So your job here is to clean up the numerator. Clean up the numerator, which means any distribution, distribute. If there's any binomial times a binomial, then FOIL. Basically, you're killing parentheses. And combine like terms. Okay. So you clean up your numerator by combining, distribute, FOIL, and combine like terms, and then make sure you factor if possible. Okay. You didn't bother to factor earlier on if it was possible because you didn't have the right numbers. Once they're combined, clean it up, factor if possible, and once you have that, now you put it back, now you put it with your final. Your denominator was done earlier, now your numerator is done. 2 times 7x minus 6. And before you move on, is there anything that can be canceled out? All your factoring's been done. You don't have to do any more work. You just have to visually see, oh, can anything else cancel out? No. This is an x on the outside, those are x's on the inside. No. That x is a term. You cannot cancel out terms. You can only cancel out factors. Factor times factor. 2 is a factor, 7x minus 6 is a factor. X is a factor, x minus 2 is a factor. They either all go or none of it goes. Okay? If there were 2 on the bottom, yes, but not this 2 locked up. That's a term, not a factor. If there were a 2 out here, yes, you could cancel it out. Not locked up in the factor. Okay. 1 over x minus 4 minus 1 over 4 minus x. You've got subtraction.
Yes, ma'am.
Are those common denominators?
Yes, ma'am.
X minus 4 and 4 minus x?
No. Opposite.
They're opposites, though they do have a relationship, but they're not exactly the same.
But if they were additional, that'd be, because it won't matter, will it?
Well, if it was addition, it wouldn't, right? If it was x plus 4 and 4 plus x, order doesn't matter in addition. They would be the same. This is like when we looked at factors of 1 last time, right? So anything that matches x plus 4, 4 plus x, or x plus 4, x plus 4, anything with addition, order doesn't matter. If it matches, it matches. With subtraction, order matters. If you have 4's and x's, but the order is flipped, they're both subtraction, but the order is flipped, you have opposites. Okay? Now remember that an opposite, okay, and I'm going to write this algebraically. If you have a minus b, for example, and b minus a, okay, so these are what's called opposites. Okay? Now, you can factor out, remember, you can factor a negative 1 out of something. So, b minus a is the same thing, since b minus a is equal to negative 1 times a minus b. Okay? Remember, we can make opposites match as long as we factor a negative 1 out of one of them. So if they're opposites with opposite order, we could turn this around to a minus b. That's a legal move as long as we factored out a negative 1. Okay? So if you had opposites, one on top, one on bottom, it was a legal move to cancel one out and you throw a negative out front, right? Here, this is not one on top, one on bottom. This is not a factor of negative 1. This is denominators, but it's the same understanding.
You just cancel out in negative 1?
Well, can I turn this into x minus 4? Is that a legal move to make 4 minus x into x minus 4?
It's not legal, no.
No. If you multiply it, yes. It is legal if you factor out a negative 1. So I can rewrite this as 1 over x minus 4 minus, let me go ahead and lock things up too. Okay. I can change this into x minus 4. That is legal if I factor out a negative 1. And I'm just going to put that up here. Remember, it doesn't matter where you put the negative 1, on top, on bottom, out front. Okay? So it's a legal move to change this to its opposite as long as I pulled out a negative.
As long as you make that a negative.
Right. Now it was already subtraction, right?
Mm-hmm.
Which means, what does this do to my operation? Yeah. So 1 over x minus 4, 1 over x minus 4 minus 1 over 4 minus x becomes 1 over x minus 4 minus negative 1 over x minus 4. I flipped my denominator to its opposite, which was legal as long as I factored out that negative 1. Just throw it in front.
So it would be plus negative.
And now it becomes plus. If this were a plus, it would become minus. It was a minus, so it becomes plus.
Is it going to be plus negative? No, it's not.
No, because minus and negative becomes a positive. If this were a plus, it would become subtraction. It just flips the sign. In this case, it flips the operation. And what does that equal?
1.
Over x minus 4. Can I cancel out that 2 and that 4?
No.
No. That's a term.
But why? I'm trying to combine the denominators. I keep trying to combine those and you can't do it.
No. What you have, your 8 equal slices of pizza, it is still an 8-slice pizza. The denominator doesn't change. The size of this denominator is x minus 4, period. The only way it would change is if you had something in the numerator that then would simplify to lower terms. You don't. 2 and 4, 4 is a term. 2 is a factor, 4 is a term. Because if it's touching a plus or a minus, the whole thing goes together. You don't need parentheses around it, but if you want to leave them, that's fine, to remind yourself all or nothing. 7x over x plus 1 plus 8 over x minus 1 minus 14 over x squared minus 1. Now I've got 3 rational expressions there, but they're joined with addition and subtraction. Now, here's the step that hopefully will help you keep your story organized and efficient. Rewrite the problem with a longer bar and with your denominators factored and locked up. Well, x plus 1 doesn't need factoring, but I'll lock it up. 8. And then on the bottom, x minus 1 doesn't need factoring, but I'll lock it up. And if the numerators could be factored, doesn't matter, ignore it. Don't. And on the bottom, here I've got x squared minus 1. Can it be factored?
Yes.
Into?